Hello all, this is Anish Thakur, Assistant Professor, Kite University, Ghaziabad, from Computer Science and Engineering Artificial Intelligence Department. I am having 3 years of experience in AI and ML domain. Today I am here to teach you about CNN. CNN stands for Convolutional Neural Networks, which is basically a technique used in nowadays artificial intelligence and machine learning. To know what CNN, we have to know little bit about machine learning and artificial intelligence. So let me start with an example. Suppose you become parents. As soon as you become parents, you know that the baby knows nothing about this world. But with time and your supervision, he will learn things on the basis of input he perceives from his senses and process those inputs in his brain and stores them. For example, as an input method eye, a baby have eyes, he perceive, he views things, he views you as a parent daily, he develop a pattern in his brain and store that information that yes, this is my father and this is my mother. In machine learning, if we treat our machine same way as a baby, so we will know that as a software engineer what we are doing. As a software engineer, we are making our machine learn same way a parent make our his baby learn. How we will make our machine learn? If let us suppose a baby is learning from his vision, his eyes, and as a software engineer, we want our machine to learn by seeing something and predict that yes, this is a father, this is a mother. So we will give as an input him a image and he will process that image in his processing unit and give output yes this is what inside the image. So whenever you want your machine to make learn that yes by looking at a picture that whatever in the picture we will use term something known as computer vision. So computer vision is nothing but a dimension in AI and ML which is basically used to make our machine learns on the basis of inputs as images or videos we give it, and it will process the patterns whatever in the images and give output what inside that image. So in the computer vision dimension we use a technique that is known as convolutional neural networks. So let's dive deep into the CNN. To know what CNN, let me give you a short example. Let's come back to your 10th class. So here's a diagram if you ever see it. So this is a diagram of a neuron from biology. What is neuron? Basically, every human having brain composed of neurons. Neurons are nothing but cells which are the fundamental unit of our brain. तो अगर जनरल टर्म्स में बात करें तो हमारा दिमाग न्यूरॉन्स के कॉम्पोजिशन से बना है जो इसकी सबसे स्मॉलेस्ट यूनिट कहलाता है. सो एज अ स्मॉलेस्ट यूनिट एंड जैसे मैं आपसे बोल रहा हूँ कि एक न्यूरॉन ही है जो पूरे दिमाग को कंस्ट्रक्ट करता है, तो इसका मतलब न्यूरॉन ही एक ऐसी चीज है जिसमें मेमोरी स्टोर होती है, जिसमें जो मैं आपको चीजें पढ़ा रहा हूँ आप उन चीजों को इसी चीज में कहीं जाके स्टोर कर रहे होंगे. तो बेसिकली अगर मैं आपसे पूछूं कि इस स्ट्रक्चर को देख के बताइए कि ये जो हम चीजें सीख रहे हैं ये इस न्यूरॉन में स्टोर कहाँ जाके होती है. So basically, this is the fundamental unit which is storing, which is transmitting whatever we are learning in our. So let me give you an example to understand how neuron works. Suppose we have two villages. Village one is our Muradnagar and village two is our Modinagar. मान के चलते हैं बहुत साल पहले इनके बीच में बिल्कुल भी रास्ता नहीं था. तो धीरे धीरे क्या हुआ, वहां के लोगों ने इनके आपस के गांव में एक रास्ता एस्टेब्लिश करने की कोशिश की. तो उन्होंने एक पैदल सा रास्ता बनाया जो बेसिकली 10 किलोमीटर का था और इस 10 किलोमीटर को पार करने में उनको लगभग 1 घंटा लग जाता था. टाइम के साथ वो रास्ता एक नैरो सा पाथ बन गया. जहां पहले 1 घंटा लगता था अब उन्हें उसी रास्ते पे चलने में 50 मिनट लग रहे हैं. टाइम के साथ वो और वाइड होता गया, अब 40 मिनट लगने लगे. टाइम के साथ सरकार ने वहां पे 2 वे रोड बना दिया, अब 4 वे लेन बन चुका है. तो जहां पे स्टार्टिंग में उस रोड पे जाने में उनको 1 घंटा लग रहा था, अब वहीं उसी रास्ते में उनको सिर्फ 10 मिनट लग रहे हैं. So, with this example, what I want to make you understand is, suppose if this village is our neuron and this village is also our neuron, with time, what happens whenever a new memory or something new image as an input feed into our system as in our brain, so they will make a synaptic terminal. They will make a kacha rasta. So it is loosely structured. If you don't revise things, suppose you learn something and you don't revise those things, this connection will be broken up. So you have to revise things again and again to make that connection more strong. So it means the way यहाँ पे कच्चा रास्ता एक 6 वे लेन बन गया जहाँ पे उसको उस मेमोरी को प्रोसेस करने में 1 घंटा लग रहा था, अब उसी मेमोरी को प्रोसेस करने में उसे 10 मिनट लग रहे हैं. सो ये कैसे हुआ? ऑन द बेसिस ऑफ रिवीजन. सो सेम वे हेयर जहां पे बिल्कुल कनेक्शन नहीं था और एक वीकली लूजली स्ट्रक्चर कनेक्शन था, टाइम के साथ जैसे जैसे तुम उस मेमोरी को रिवाइज करते जाओगे वो और स्ट्रांग बनती जाएगी और स्ट्रांग बनती जाएगी और स्ट्रांग बनती जाएगी, और ये मेमोरी इतनी स्ट्रांग हो जाएगी, सेम वे यू रिमेम्बर योर घर का एड्रेस. So basically, what I am trying to understand, make you understand is where this memory is going to be stored in these connections. So whenever you suppose I teach you AML, you make such type of connection, and after 10 years I ask you, tell me something about ML. So from here you will take only 10, maybe 10 micron seconds, tenth part of a second to fetch that knowledge that yes, this is machine learning. And if you don't have, revise the things I teach you, so with time, what happen? The reverse order. The connection, the learning I make you understand the things will broke that connection. So that's how neuron works. We mimic this concept in machine learning. So using this biological neuron, which is basically a fundamental unit, we create a unit in mathematical terms, which is called as McLaughlin neuron model, where this is our input method, this is our processing unit, and it will give us a output. So it has three layers, same way we have our neuron have a three unit. So it will process things, it will transmit things, it will store things. So this way how neural networks work. This is the system how neural networks work. Let's dive deep into a neural network. Neural network is nothing but a perceptron. Suppose in first layer, which is our input layer, and the second layer, which is our processing layer, and third layer, which is our output layer. या सो हमने देखा कि कैसे एक न्यूरल नेटवर्क जो बायोलॉजी से बायोलॉजी का कंसेप्ट था उसको हमने मिमिक करके एक मॉडल बनाया जिसे हम परसेप्ट्रॉन बोलते थे. हमारे परसेप्ट्रॉन में बेसिकली तीन लेयर्स होती हैं. फर्स्ट वन इज इनपुट लेयर, सेकंड वन इज आवर प्रोसेसिंग लेयर, एंड थर्ड वन इज आवर आउटपुट लेयर. So I will make you understand by a mathematical example how these things works. So let us suppose a student have subjects deep learning, AWS, data engineering, and he attained marks like 75, 65, 80 in these subjects. Having a subject have a credit of 4, this one have 3, and this one have 5. So if we give these as an input with weights as credits into our system, it will produce a summation of those marks by using this formula. So let us suppose we have a result something as 95. So out of total 300, what it will do, it will apply a activation function. Activation function is nothing but it works something like as a threshold. Suppose किसी बच्चे के 100 में से passing marks 33 हैं. So if he will able to achieve 33 or more marks, he is pass, otherwise he will fail. So it's like a if else conditions. So 95 out of 300. So if we take the one third part of it, so it means that student is pass or either he is fail. Then what we will do in machine learning, we calculate that we are trying to predict that this student is going to pass, and do our model, do our summation function, predict it as a pass or fail. So we put that in a formula like y minus y predict is something which is known as pass or fail, which we take in a binary number 1. So 1 minus 1 0. So it means our prediction have no error. So we don't require any updation. So that's way how mathematically a simple perceptron works. We use this concept to mimic, suppose here not having a simple formula of x greater than 33, we have a full CGPA formula. So it don't have a single component, it have n number of components. So when a perceptron have n number of components, it will becomes a hidden layer. And it becomes a hidden layer, so perceptron becomes a new artificial neural network. So this way how artificial neural network works. So I told you that we are going to learn CNN. So we learn AIML, then we learn how ML works, then we learn how perceptron works. From perceptron we comes to AML. Now we proceed to CNN. CNN is nothing but a type of ANN in which we जहाँ पे हम नंबर्स ना देके मशीन को इमेजेस दे रहे होते हैं और इमेजेस से हम उसे सिखा रहे होते हैं कि कैसे इन इमेजेस में डिटेक्ट करें कि इस इमेज में है क्या. सो लेट्स स्टार्ट. ओके, हमने एएनएन के बारे में देख लिया. अब हम देखेंगे कि सीएनएन एक्चुअली में काम कैसे करता है. The structure I showed you, this is the same structure we used in CNN, but just this hidden layers change. So to know about CNN, we have to know something little about what as an input we are giving to our CNN models. हम क्या करते हैं, अपने मॉडल को इमेजेस देते हैं और उन इमेजेस के बेसिस पे मशीन प्रोसेस करती है और उससे देखती है कि इस इमेज में है क्या. बट वो इमेज को प्रोसेस कैसे करती है, उस इमेज में एक्चुअली में होता क्या है. जिस तरह से बायोलॉजी में फंडामेंटल यूनिट न्यूरॉन थी जो हर एक प्रोसेसिंग कर रही थी, हमारे मिमिक्ड मॉडल परसेप्ट्रॉन में हर चीज परसेप्ट्रॉन में काम कर रही थी, उसी तरह इमेजेस एज अ इनपुट आल्सो हैव समथिंग as a fundamental unit. So if you see here, this is a picture of black and white line. If I zoom here, you will find something a line like this. अगर मशीन्स की भाषा में बात करूं, मशीन नहीं समझती कि इमेज है क्या, मशीन समझती है नंबर्स. सो अगर इस लाइन को मशीन रीडेबल फॉर्म में चेंज किया जाए तो हमें कुछ ऐसे ऐसे नंबर्स दिखेंगे. ये नंबर क्या रिप्रेजेंट कर रहे हैं, बेसिकली दीज आर पिक्सल्स. So wherever there is a zero written, it means the pixel have a zero value. Wherever these pixels become dark, 252, 199, so these pixels are having black color. So basically, wherever the pixel have higher value, it have a higher color is there. And where pixel is showing zero, it means this pixel is don't have any it pixel have uniformity or it's not activated. So this is a black and white image. Same way we have a colorful image here. If in colorful image I will zoom here and fetch a pixel, and I want to understand what is the fundamental structure of pixel. So what you will find, pixel is having a composition of 24 bits, having 8 bits for red, 8 bits for green, 8 bits for blue. So it have red, green and blue, three primary colors. So what in a pixel is there? We map pixels from 0 to 255 range. Suppose a pixel having 24 bits. So if I put in a pixel 0, 0, 0, 0, 0, 24 times, it becomes a black color. And if I put 24 times 1, 1, 1, 1, it becomes a white color. In between that, all the combinations of these 24 into 23 into 22, these are the different colors combination we have. So this way, using those numbers, we create a color. That color is a composition useful in creating images. So images is nothing but pixels of 24 bits having numbers written in 0101 format. So yeah, here comes the architecture of CNN. I told you at the time of perceptron, we have an input layer, we have a processing layer, and we have an output layer. So what we need to understand is whatever is in its hidden layer or processing layer is there. So if you see here in a CNN architecture, if you feed image as an input, and what processing it will done in its hidden layer. So we have something called as convolutional, something called as pooling, and something called as flattened, something called as fully connected, and something called as softmax. We will understand each term one by one. So let me take an example. So here's our convolutional, here's our pooling, here's our flattened layer, here's our fully connected layer, and then is a softmax. I take a mathematical example. Suppose we have an image and we are seeing its mathematical values. So what I do here, I create a 5 by 5 matrix. So this is representing, one is representing a black color, and 0 is representing a white color, or you can swap the things like this is white and this is black. So if you see here, the 60% of the image is one color and 40% of the image is another color. So machine understand numbers, so I simply represent it with 1 and 0. Either it's 24-bit single number is there. So as an input image, when it goes into the CNN, so what we will do in convolutional, we apply a 3 by 3 filter. Suppose it needs to understand this pattern. Suppose machine needs to understand these patterns. So it will take a filter. Filter is nothing but a matrix of values which able to detect what kind of patterns in our images. So it will take this filter and put it here in 3 by 3 and perform some multiplication like this. Same way like wixi plus w2x2 plus w3x3. So it will perform first convolutional here, then there's a value comes like this. We will store that value here. Then we will perform a for loop kind of thing like a iteration. Now the picture will not go. Now the convolutional will not happen on this. Convolutional will happen on these numbers. Then these numbers. Then it comes in looping here, here, here. So in at last from 5 by 5 by 5 by 1 image, you find a final feature map that looks like something like this. These are rough numbers just to make you understand conceptually. So here convolutional, what it do, it convolute these things. What are these? It pick up the highlighted pixels from here. Like here comes the 000 due to this effect. Then comes the 333. So basically here the pixels are having no color. So as soon as it transfers to 000, the pixels transform to max values. So it is fetching the most highlighted pixel from our feature map. Then comes the ReLU. ReLU is nothing but an activation function. What it will do, either it will transform a value, either it will say either a pixel is activated or either it is not activated. If a pixel have negative value, it transform that value to 0. And if a pixel have positive value, it will say its pixel is activated. Same way I told you, there is a white color 11111 and there is a black color 0000. So either it's 0 or either it's up to 1111. So it always having range 0 to x. So we put these values into this ReLU activation function. If there is a negative value, it transform that value to 0, and if there is a positive value, it leave that value that way. Now this feature map, on this feature map, we apply pooling layer. When we apply pooling layer, we have some output like 3333. So from 3 by 3 matrix, it become a 2 by 2 matrix. So after the max pooling happens, we again comes to the final feature map. It will also then again do ReLU, again do max pooling. It depends upon you how much layers you want to create. Like this is a one layer, this is a second layer. So after that, when all the layers are completed, what you will do that this 2 by 2 matrix dimension data, you transform that data in a 1D matrix. So now these are the input which are same as we fetch our deep learning marks in perceptron example. So this is the format This is the number now machine is able to use easily. So this whole process is all about transforming this image into these numbers which machine will use to detect those patterns. So after this fully connected layers, we put into our flattened layer, we put that data into fully connected layer. So it will give us some values like this. Then we have another activation function which is known as softmax. Softwares do nothing. It will create probability using its formula. For example, for class 1, that is our 111 example, 99.919%, and class 2 probability is 0.011%. So basically, it is detecting some patterns. It is saying class 1 have 99% matching, that yes, this pattern is detected. So this way, mathematically, CNN works. Now let's dive deep into the layers. Each we will see each layer how these layers work. Now see, this way convolutional is happening. From here it is doing that matrix multiplication and fetching this number 4, 3, 4, then 2, then 4. So this is the whole RGB channel. For this is happening for red color, then for green color, then for blue color. This is our filter. This filter is doing this multiplication. So this with this multiplication, we have these numbers. When these numbers come, these negative will when fetched to the value, it will transform these numbers to zero. And these, so yeah, so this is the full RGB channel where convolutional is happening. It is fetching these values here. This is kernel is applying on this the matrix multiplication whole this processing complex processing. It will fetch us numbers like -25, 466, 466, 475. Then comes the activation function. What do activation function do? Either the value is 0 or either it's x. X means from 1 to x range. So from black after black color to all the white colors combination. So either the pixel is not activated or either the pixel is activated. So if it having a value, it is having a value negative, it will transform that value into 0, or the positive values remain same as it is. So whenever 0 comes, it transform it to 0. Whenever a negative value comes, it make it 0. And when a positive value comes, it leave value as it is. This is a padding. Padding is nothing but a when we want a extra space in the corners. These corners contribute don't much, so we use padding to make sure that no pattern left behind in these corners. So that's why we do padding, which is of two type: valid padding and same padding. Then comes the pooling layer. Pooling layers happen two ways. How? One is max pooling and one is average pooling. In max pooling, what we will do, we will take a 2 by 2 filter, we apply it here, and we watch in either of the four value which value is maximum. Whatever the maximum value, we fetch that value and put it here. Like here, the value is 20. And in average pooling, we take the average of these four numbers and put it in our matrix, the final feature map. So the max pooling is always better because it fetch you the greater numbers, and these greater number help us process things good. So yeah, there is a simple architecture of LNet architecture. LNet architecture is the basic version of CNN, where we are putting some images like 28 by 28 and sorry 32 by 32 pixel set, and it goes to the convolutional happen on that image, then pooling happen, then again convolutional, then pooling, then there's become a dense layer, flattened layer, fully flattened, fully connected layers, and then it goes to the software. So this way our LNet architecture give us results. So this is the whole architecture of our LNet architecture. Okay, now what I will do, this is all theory part. So what I do here for this example, what I do, I also created a code which is basically a real life application to show you how CNN really works with the method of codes. So let me just make a setup. Yeah. So here, let us suppose you have images of written digit like 1, 2, 3, 4, 5, 6, 7, 8, 9, and you want to make your machine learn that how by whenever you fetch an image of such digits, it will able to detect how whatever written in that image. So in basic ML, what we have there's a concept known as pipeline. Pipelining is nothing but a like a water flow waterfall model where we perform a step-by-step operation in coding. With that scenario, we will able to fetch whatever the target we have in our code. So to develop a basic CNN model, here what I do is I just use some libraries like TensorFlow, NumPy for numerical Python, Matplotlib to visualize things, to plot some graphs. And in TensorFlow, I am using the dataset of MNIST, which is basically a data recognition predefined dataset, and I'm using sequential from models. So basically, we are using a simple sequential CNN models. In CNN models, we had to perform some layers like convolutional, max pooling, flat dense, and pre-processing to that image. Then I just load the dataset in xtrain and xtest. In machine learning, what we do, we put some data in training and then put some data in testing. In training, we fetch input with outputs. Yes, this is the 7 return, this is the 8 return. In testing, we don't give output to our data. We perform some pre-processing to our data. We shape that data, these images into numerical values and divide them, map to the 255 values. So this is the whole structure of images in our data set. This is a sample image performed by, drawn by this matplotlib graph. So here's how 5 is written in those images. So this is the basic code of CNN model. Here I told you that we are using sequential model. In this sequential model, I use the convolutional layer, I use the max pooling layer, I use convolutional again, then max pooling, then flatten, then dense. In those dense, you will see that this 32 is representing the number of neurons it is going to have. And this 3 by 3 is nothing but its filter. The activation function we are using ReLU, and this is the input shape of our images. So we fetch this image, and in these neurons, we convolute these into max pooling of 2 by 2. Then again perform convolutional from 32 to 64, then max pooling, then flatten, then dense having 128 neurons, then dense again have 10 neurons. So this way you can put different number of layers using these keywords of convolutional and max pooling. So this is how we compile our model. We put some optimizer in that. Then we train our model. We put our model to 5 epochs, matlab 5 loops. So it will iterate these results up to 5 times. Then just to check whatever the accuracy comes of our testing data, we perform a X test Y test evaluation. So it will give us that our accuracy is 98.65. So now here's a simple code. What I am doing is I am using a predefined image in from my local drive. I just upload that image and show you how this will able to detect whatever the written in this image. So this is the 3 written. So yeah, my model is predicting this is 3. Confidence is 100%. So it is saying that 100% this is 3. Let us suppose let's take another example like this is a 7 written. So yeah, it is predicting the digit is written is 7. So confidence is 99.9%. So this way you can code your simple CNN to just recognize whatever the digit is there. So we use from this MNIST data, which is a predefined data, these images, and we build a basic CNN model. And this CNN model, we perform some test accuracy, and this is a simple code to create this image. This is the code to upload that image from your local drive. And this code is nothing just to, whatever the image you put, it will make that image in proper format aligned to the MNS dataset. So this way we are predicting, yes, this is our whatever written in this image. So congratulations, you make your baby or your machine learn to visualize things by watching whatever written in those images. That's all for the day. Thank you and have a nice day.